Up to this point, I've taught you the basic idea of exponents. We've talked about that. And we talked about what to do when you have something multiplied by something else and each of them have an exponent and the bases match. You can add those exponents together. Now we're going to learn about how to handle a situation when you have something like this. We have something squared and it's raised to a power. Or in a more general sense, you have an exponent raised to another exponent. Raised to another exponent. The way you do that is you leave the base the same and then you multiply the exponents. 4 times 2 is 8. So it's 3 raised to the 8th power. And I want to briefly show you how this is possible so you know that I'm not just making up things. If you have 3 squared raised to the 4th power, what does that mean? It means you have 3 squared times 3 squared times 3 squared times 3 squared. Everything in the middle is multiplied by itself 4 times. That's the definition of what an exponent is. But notice that everything in here is squared. So really what I have is 3 times 3, 3 times 3, 3 times 3, and 3 times 3. 1, 2, 3, 4, 5, 6, 7, 8. This is 3 to the power of 8, which is exactly what I told you. So I'm showing you by an example. Basically, if you have a power raised to another power, you just multiply the powers together. So they're all simple rules. It's just that, like anything else, you have to have practice with the rules, or you're just not going to do. You're not going to do well with it. So let's practice this. What if we have y to the power of 5 raised to the 3rd power? We have something to a power raised to another power. So we just say it's y, 3 times 5 is 15. That's as simple as that. You multiply the guys. So the bottom line is, sometimes you add exponents if the two terms are multiplied together, but if you have a power raised to another power, you have to multiply the exponents. All right, what if we have a to the 3rd power raised to the 7th power? 3 times 7 is 21. All right? And what if you have something like x squared times x to the 3rd inside the parentheses, and you raise the whole thing to the 5th power? How would you handle this? Well, I'm teaching you another rule kind of on the fly as we go. When you have lots of different things multiplied together inside of a parenthesis and you're raising them to a power, you can sort of distribute this power in to those exponents. Kind of like we do when we distribute, anything else, when we multiply things. So what you'll have is x, 2 times 5 is 10, and it's multiplied by x, 3 times 5 is 15. Like this. So you get x to the 10th from this, x to the 15th from this, and notice when we look at this, we can actually combine these guys because we have common x. We add the exponents in this case. So we'll get x to the 25th. So this is the answer. Now, notice we did it this way. I showed you how to distribute the exponent in, getting these two terms, and then you can add the exponents, getting the answer. But there's another way to do this problem. There's always different ways to do problems. What I'm going to do now is simplify what's inside the parentheses first. Notice I have x squared and x cubed. I can basically convert that to x to the 5th power because I can add these exponents in the middle. Now I have x to the 5th raised to the 5th power. So 5 times 5 is 25. So no matter how you do the problem, you're going to get the same answer. And there's always, I can't say it enough, there's always going to be more than one way to do a problem. And this is a perfect example. All of these simplifications of exponents are going to happen like that. You could combine them first and then raise them to a power, or I can do the powers first and then combine them at the end. You should always get the same answer each time. In fact, it's a good way to check your work. All right, let's say we have 3 times z squared times z cubed, all raised to the 5th power. All right, all raised to the 5th power. And we want to simplify this. Now, there's a couple ways we could do it. I could distribute this 5 in everywhere. It would have to go to the 3, and then it would have to go to the z squared, and the z cubed. But, just to show you different ways to do the problem, I'm going to instead do it like this. Let's work on the inside first. I have a z squared, and a z cubed. I have the same base, so I can add these together, and I'm going to get z to the 6th by just adding the exponents. Now, everything is still raised to the 5th power. Now, I can't really simplify anymore, so what I'm going to do, I can't simplify inside here anymore. So I'm going to distribute this 5 in to both places. Now notice the 5, the exponent 5, is going to go and apply itself to the 3 and also to the z to the 6. So anything in there gets affected. So what you're going to have is 3 raised to the power of 5 times z raised to the power of 6 times 5 is 30. So you're going to have 3 to the 5, z to the 30th. So here it just, notice this is like 3 to the 1. So 1 times 5 is 5, 6 times 5 is 30. And you get the same answer either way. We combined first and then applied the exponent. If I apply the exponent to everything individually and then simplify, I'm going to get exactly the same answer in that case. And that's always the way it should be. Okay? What if we had something like r to the 3rd power times r squared raised to the 4th power multiplied by r cubed r to the 5th raised to the 2nd power? So again, there's many ways that we could do this, but again, to show you, I could combine these guys, and then I could combine these guys and then raise the powers, but just to show you different ways to do it and show you the power of the algebra, I'm going to apply the 4 to both of these guys first. So what I'll have here is r cubed raised to the 4th power, r squared raised to the 4th power, and here, when I take and apply here, I'm going to have r cubed raised to the 2nd power, r to the 5th power raised to the 2nd power. So basically you apply the exponent to everything. Here we have r to the 12th because 3 times 4 is 12. Here we have r to the 8th because 2 times 4 is 8. Here we have r to the 6th, and here we have r to the 10th. Now look, I have r's everywhere with different exponents. I can add these guys together. So what I'm going to get, 12 plus 8 is 20. And then I have 30 from this, and then 36. So r to the 36. So all of this mess simplifies down to r to the 36th power. And it's going to work the same way. See, here we distributed first. If I combine this guy and get something, and then I combine this and combine something, and then apply the powers, I'm going to get exactly the same answer in the end. Okay? So let's go on and do this guy. X times y raised to the 3rd power. How would you simplify this? Well, about the only thing you can do is apply this exponent in like this. So what you'll get is x to the 3rd power, y to the 3rd power. 3 times 1 is 3. 3 times 1 is 3. And you can't do anything else here. You can't combine these because I have an x here and a y here. I can't add these exponents because I've got different guys going on there. So I'm basically done. All right. What if I have r to the 3rd times s squared all squared? Well, I can't combine these guys in the middle because they're different base variables, so I'm going to apply the 2. r, 2 times 3 is 6. S, 2 times 2 is 4. And this is the answer. I can't combine these anymore because I have r's and I have s's, so I can't do anything else there. So we're applying the rules. It looks like a lot of work and a lot of things to remember, but really there's only a few different rules and a lot of practice to help you get good at it. All right, let's say we have negative 2 times r squared times s to the 3rd times t all raised to the power of t, of 3, I should say. Okay, so we look inside, we can't really combine anything. We have r's and s's and t's, so we can't combine any exponents in there. The only thing we can do is distribute this exponent in. It would apply itself to the 2, it would apply itself to the r squared, it would apply itself to this, and it would apply itself to that guy. So it's going to apply itself to everything. So what you have here is negative 2 raised to the power of 3. Then you're going to have, just to make it totally clear, r squared raised to the power of 3. Then s to the 3rd raised to the power of 3. Then t raised to the power of 3. Just to be absolutely clear so that you know what I'm doing, I'm applying the cube to everything. Now when you look at this, negative 2 raised to the power of 3 is negative 2 times negative 2 times negative 2. So if you think about that, that's going to give you negative 8. Here, you have a power raised to a power. So you multiply. 2 times 3 is 6. Here, same thing, you multiply. 3 times 3 is 9. Here, there's nothing much to do except apply it. Or you could say 3 times 1 is 3, I guess, if you want to do it that way, just to remember it. So you have negative 8, r to the 6th, s to the 9th, t to the power of 3. All right, so we've done a lot with multiplying exponents together and how to handle that. We've done a lot with raising an exponent to another exponent. Now we're going to go figure out what to do when you have some stuff on the top of a fraction with exponents, and then you have stuff on the bottom of the fraction also with exponents. When you get the hang of it, it's not going to be very hard at all. In fact, it really isn't hard. It's actually kind of fun, in my opinion. All right, so what if you were doing something like a over b, and you raise the whole thing to the third power? How would you do that? Well, it's something you need to learn, but when you have a fraction and you're raising the whole thing to a power, you can apply the power to the top and the bottom of the fraction separately, like this. So this is the only thing you can do. This is the answer. So the cube gets applied to the top, and the cube gets applied to the bottom of the fraction. It's kind of the same thing as the distributive thing when the cube goes and affects everything inside. Well, the cube goes and affects everything inside of here as well, top and bottom. So it's kind of an expansion of what you already know, really. So let me switch colors, and then we'll say, what if you had something like, we'll kick it up a little bit, x squared over y cubed, all raised to the fifth power. So you can't do much inside because you have x's and y's, but you do have this fifth power here that you can operate. So on the top, it'll be x squared raised to the fifth power. On the bottom, it'll be y cubed raised to the fifth power. The exponent applies to the top and the bottom of the fraction. Now we revert back to what we know. We have a power raised to a power. So on the top, we multiply 2 times 5 is 10. On the bottom, we multiply 3 times 5 is 15. And this is the answer, x to the 10th over y to the 15th. We just have to handle it one step at a time. Apply the exponent to the top and separately to the bottom. Then you use what you already know to simplify these exponents. So it's a good example in algebra of how we learn these little rules and we kind of incrementally build. See, if you didn't remember how to do this, then you couldn't finish this problem. And so a lot of students, if they don't understand something, they'll just kind of punch through it and get on to the next section, and then they're even more lost. So it's going to actually save you time if you practice this and get really good at it and then move on, rather than trying to punch through it and then trying to, do poorly later on. It's just not going to work out in algebra. All right, so we have this guy, and we'll switch colors. Now, what if we had something like, negative 2a over b, all raised to the power of 5. It's exactly the same principle. We've got a fractional raised to an exponent, so it applies to the top and to the bottom. So to make it clear, you have negative 2a on the top, all of it's raised to the fifth. On the bottom, you're also raising it to the fifth. Now, you should recognize the top. What do you do when you have lots of things inside of parentheses raised to a power? You distribute the power in. So really what you have is like negative 2 raised to the power of 5, and then you apply it to the a. You have a to the 5, and then you have b to the 5, and you can't do anything with the a's and b's because they're different. So basically, this is the answer. Now, you could go in your calculator and do negative 2 times negative 2 times negative 2 times negative 2 times negative 2, and you could put a number there, that's fine, but I'm just going to leave it like here just to illustrate what's happened. You've applied the exponent 5 to the top and to the bottom, and then here, for the top, you distribute it in because we've been doing that before. So you're using an earlier skill to apply to these later problems.